Hi everybody. Today I want to generalize an SMO Senior problem where the constant was the integer 12, okay? So again, the problem was stated more or less like this, except there was a 12 right here. I want to generalize this to where we get a minimum value of y minus x in terms of k, okay? So it turns out making substitutions is the right way to go here. Notice that this particular substitution right here would certainly imply that a minus b is equal to k. Right, and you can just get that directly from here, right? Okay, now also a cubed is y. It's just because cubing and cube rooting are inverse operations, right? And similarly, b cubed is equal to x. So what we get right here is b cubed, y minus x is equal to b cubed minus, or a cubed minus b cubed, right? A cubed minus b cubed. And so you can see the motivation for this substitution is this is a very well-known result, the difference of two cubes. We'll make use of that as you see. So let's move along. So this is the thing we're trying to minimize, y minus x, and we've seen it's equal to a cubed minus b cubed based on the substitutions. Now notice that a minus b is k, so that's where this k comes from, but also a is equal to b plus k, right? Okay, and so I'll try to minimize the commentary. The rest of it, I've written it down. You can see how this all happens. The k and then b plus k. Okay, I said I'm going to quit talking. All right, and so we get to this stage right here. The motivation for this step is to complete the square. Now, as I'm running out of letters here, but remember the motivation for the complete the square is that you can get it in this kind of vertex form where you can inspect and see where it's minimum. Okay, so anyway, but it's, if you guys are, any of you struggle with that, and I remember the first time I had a teacher show me the complete square, I go, where's all the magic about taking half of the, the linear coefficient? But it's because of this, it's just this in reverse. Okay. Again, and once you realize that the motivation to go from this step to this step is this too really is exactly comes from here basically. It's just in reverse. You have to take half of this, but half of this happens twice, so you get back to this original object, right? But in the process, you quote made a mistake. K over 2 squared is this, so you have to subtract it off. Okay, and then common denominator here is certainly 12, and we get down to this very nice object here. And remember, this is equal to y minus x, which is the thing we're trying to minimize, that difference between the real values y and x is what we're trying to minimize. Now you can clearly see that this thing achieves a min. Its minimum at b is b equals minus k over 2, right? Yeah, b is equal to minus k over 2. And I should have the word when in there, I guess. Y minus x is minimum when b is equal to minus k over 2. And it's very clear that that minimum value is the minimum value of y minus x. Again, this part would vanish to 0 if b is equal to minus k over 2. When you multiply through here and 3 over 12 is 4, you end up getting k cubed divided by 4. And so that is the answer to the question. For any integer, positive or negative, this is the solution. Y minus x is equal to k cubed over 4, and that would be its smallest value. Now the problem that happened in the over at the COCO website that does a lot of SMO work, review stuff, there's a trainer there that does a lot of videos, and their example was k equals 12. Okay, k equals 12. And so let's come back here and see what's going on. That means the minimum value, y minus x would be minimum. Whoops, that always happens. Y minus x would be minimum would be min of, what is it again? 12 cubed over 4. Min of 12 cubed over 4. And y'all, I had to use a calculator. I'm not going to multiply this out by hand, but I don't know. I don't know if the practice competitors have the cubes memorized too. But that's kind of a pain. But 1728 is 12 cubed and divided by 4. This is about what something I could come close to doing in my head here. It's 432. So that was the answer to the question, the practice review thing for the SMO Senior. So anyway, that's the answer in this special case. But the triumph, I guess if you want to call it, this is true in general for an arbitrary integer. And so I guess up here I better write that down. Y minus x is a minimum of k cubed over 4. Okay. So again, that's the answer to the question. I suppose y minus x achieves a minimum value of, that's kind of awkwardly worded, but anyway, get the picture. So I guess we're done. Okay. Thanks for viewing.